Hello students, today we are going to discuss about coordination and response. After this lecture, you would be able to know about types of coordination, difference between nervous coordination and endocrine system. You would be able to know about reflex action and transmission of impulse across synapse. So first of all, we should know about body coordination. Body coordination means like all the body parts work in a coordinated way. All parts of the body perform a specific function with a coordination. So this is body coordination. Now we have two types of coordination. The first one is nervous system, okay, and the second one we have endocrine system. The first one is nervous system, and this system specialized elongated cells are involved that are called neuron. Okay. While another system, it is endocrine system. This is the system of hormones. In this coordinated system, hormone play important role. Hormone produced by specialized body and specialized structure that are present in our body called gland. Okay. Now, because of these two systems, our all body parts work in a coordinated way, and they're having a communication with each other. Okay. So first of all, I will go in detail about nervous coordination. Nervous coordination is the system of neuron. Nervous coordination divide into two categories. The first one is central nervous system, and second one we have peripheral nervous system. Central nervous system actually consists of brain and spinal cord. Okay, the system of brain and spinal cord is called what? Central nervous system. For example, it is brain, okay, while this one is spinal cord. So the system of brain and spinal cord collectively called what? Central nervous system. Okay. Now, from central nervous system, neuron spread in our body. From central nervous system, neuron arise and that spread in our whole body part. Actually, our whole body part connected with central nervous system through neurons, and that are called peripheral nervous system. It means those neurons that spread in our body and that connect our body with central nervous system, that is called what? Peripheral nervous system. Okay. Now let's discuss about this in detail. First of all, we should know about sensitivity. Sensitivity is the ability of an organism to detect change in internal and external environment and generate appropriate response. Okay. Now, the ability of an organism to detect change in internal and external environment. For example, internal environment, water level increase in the body, or external, for example, you touch hot object or like someone touch you. So all these are stimuli. Stimuli is actually what is change in an environment. Change in environment is called stimuli. That stimuli will detect by receptor. Receptor may be specialized cells or these may be nephron ending. Like in our skin, there are different receptors for temperature, for touch, for pain. So we can feel all these stimuli through skin. Now that receptor will give that receptor will convert that into impulse. Impulse is actually electrochemical signal. This is the signal that traveling through neuron. So that receptor will give that impulse to neuron. Or if it is neuron ending, so definitely that neuron will take that to your central nervous system. So those neurons that are taking that stimuli, that are taking that impulse to central nervous system, that are actually afferent neuron. An example of afferent neuron is sensory neuron. So sensory, this is a general term, afferent, the neuron that are taking impulse. So which neuron are taking? Sensory neuron are taking impulse to your brain and spinal cord, to CNS. That is actually integrator. CNS, central nervous system, is integrator that process the data appropriately. The response by CNS that will carry by efferent neuron. Efferent neuron is actually motor neuron. Motor neuron will effector jumps from the internal environment body. Receptor body detect change in the environment. Like thermoreceptor, it's in the part that responds to. Now, responding to environment, how we are going to give response to environment. So first one is stimuli, after that receptor, and then coordinators. Coordinators means central nervous system will do coordination, and it will decide, and after that impulse will take to effector by motor neuron, and then response will make. Now, you can see, for example, as you touch a hot object. So temperature receptor in the skin will detect it. And that will move to central nervous system. That impulse, that signal, that electrochemical signal, it will move to central nervous system. And then through motor neuron, muscle will activate. And which muscle? Arm muscle will activate because your arm touched that hot object. So your muscle, you will pull away your hand. Okay. Now response can either be conscious or it may be reflex. Reflex means it may be involuntary. You will give response, but you will not know. It may be conscious. Conscious means you know about that. That is voluntary action. Okay. Now, this is another example. For example, there is a beautiful flower and you just look to that through your eye. So in that case, your eye is your receptor. And that brain will decide, and that will give impulse to motor neuron. So motor neuron will stimulate, and that motor neuron will take that impulse from the brain to effector. Effector in that case is hand, in that will give signal to your hand that you can take that flower. Okay, so that taking of that flower is actually your response. All right, now we will discuss about peripheral nervous system and central nervous system, as we discussed already. Peripheral nervous system consists of sensory neuron, okay, and motor neuron. Okay, sensory neuron and motor neuron. Sensory neuron conduct signal from receptor to CNS, while motor neuron conduct signal from CNS, from central nervous system, to effector, such as muscle and gland. So this one is sensory neuron and this one is motor neuron. Okay, while this one is interneuron or intermediate. This neuron is present in brain and spinal cord and are confined to, this is confined to central nervous system. Okay, so impulse will come like this through sensory neuron, then intermediate, and after that it will reach to effector with the help of motor neuron. Okay, now it means that sensory neuron and motor neuron both are the part of peripheral nervous system, while interneuron is the part of central nervous system. Okay, so nervous system coordinate and regulate body function. We will discuss about now structure of neuron and types of neurons. First of all, we should know about what is impulse. Nerve impulse are electrochemical signal. It's actually electrochemical signal. They transmitted along the cells that are transmitted along the specialized cell that are called neuron. Electrochemical signal mean that signal, it's a specialized signal that produced is a result of entry or exit of ions to neuron. Ion mean like sodium and potassium, but we will not go in detail in that. Okay, so that is called impulse. So impulse, once again, is an electrochemical signal that are transmitted along a specialized cells called what? Neuron. Now, structure of neuron having three basic parts. The first one, cell body. Cell body is consist of cytoplasm. You can see this one, cytoplasm and nucleus. While dendrite, second one is dendrite. It's a like projection, cytoplasmic projection from cell body. Okay, so this projection is called dendrite. While a long projection from this cell body is it's long than dendrite. Dendrites are many, okay, and like many projection and short than axon. While this one is long projection, that is called what? Axon. Now, axon may be covered with a specialized cell called what? So the first part I told you 1, 2, and 3. This is axon. Okay, up to here it is clear. Now these are extra thing I just want to tell you that axon is covered by specialized cells called what? Schwann cell. Okay, this Schwann cell may contain a fatty material called myelin. Okay, that's why this Schwann cell covered the neuron. It make a sheath that is called myelin sheath. Okay, why? Because this Schwann cell contain fatty material called myelin. That's why when it covered the neuron, the sheath that form, it is called myelin sheath. The layer it form, it's called myelin sheath. That myelin, it is an insulator that protect the loss of impulse. Okay, while these are axon terminal. Okay, so this is the structure. You can see this yellow color with the nuclei. So this is actually Schwann cell. Okay, so this is about structure of neuron. Now, you can see dendrite collect electric signal, cell body integrate incoming signals and generate out going signal to axon, while axon passes electric signal to dendrites of another cell or to effector. You can see the signal is coming like, you know, the dendroid, okay, taking, and then it move toward axon terminal. So this axon terminal may attach with the muscle or gland, or it may give the signal to another dendrites of another neuron. Okay, you can see these are dendrites, or it may connect it with muscle or gland. Okay, all right. So sensory neuron, as we discussed, that carry impulse from receptor to CNS. Remember, and sensory neuron, the cell body is in the middle. Okay, while in motor neuron, you will see it now, the cell body will be in the end. So sometimes you can face a question that what kind of neuron this is. So you should be like a long axon and cell body at the end, so that will be motor neuron. Okay, while the cell body is at the middle, so that is sensory neuron. Okay, all right. Now, relay neuron is also called intermediate or interneuron. They transmit impulse from sensory neuron to motor neuron. It means like it is present in central nervous system. It is present in brain and spinal cord. So when the impulse go through sensory neuron, it will reach to CNS. In CNS, there is a relay neuron. So relay neuron will process that, and then the impulse will transfer through relay neuron to motor neuron. Now, here, if you see it here, the cell body is also at the end, but is compared to motor neuron, the axon of this is very short of relay neuron. Okay. This is motor neuron. You can see it here. Carry impulse from CNS to effector. That effector may be muscle or gland. Okay. So this is dendroid and this is axon. That axon reach and it attach to muscle or gland. Okay. Now in this case, it's stimulating muscle. Okay. All right. This is one of the past paper question. So receptor. So definitely receptor, like, you know, receptor will receive stimuli. That stimuli will convert into impulse, and that impulse will carry to central nervous system by sensory neuron, as we discussed already. Sensory neuron. Okay. Now from central nervous system, that impulse will go through motor neuron. Okay, through motor neuron, it will reach to where? To effector. So here it should be effector. Is it clear? All right. Now, this is very important topic. Transmission of impulse across synapse. Like, what is this? First of all, we should know about synapse. Synapse is actually a structure that permit a neuron to pass an electric or chemical signal to another neuron. Synapse is actually the gap between two neurons. For example, it is one neuron, okay, and this is the dendroid of one neuron, and this is the axon terminal of another neuron. Okay, now you can see here from, for example, impulses coming through this neuron like this. So this impulse when reach it here, this is empty gap. This gap is actually synapse. So question is how this if impulse is coming, impulse is actually what? It is the movement of sodium ion. Okay, like when impulse is coming and when it reach to this terminal, so how it will move from this neuron to this. This is empty gap. To this empty gap, it will move through a specific mechanism. We will discuss about that now. So the first neuron through which it is coming, that is called presynaptic nerve, like this one. You can see this post presynaptic nerve through which impulse is coming. Pre first, while post, this one is post synaptic nerve. From this, the impulse will have to move toward here. But how it will transfer, how post synaptic nerve will stimulate, we will discuss about this now. All right. So first of all, let's suppose this one is post, this one is presynaptic nerve. Okay, through this impulse is coming, while this one is postsynaptic nerve. Okay, now let's suppose impulse is coming here. When impulse reach here, what will happen? Specialized channel will open. Through those channels, calcium ion will enter to this axon terminal. So to presynaptic nerve, what enter? Calcium ion enter through specialized channel. That channel will open, and through that influx, that's called influx. That entry is called influx of calcium ion. And when calcium ion enter, so remember in this presynaptic nerve, these are vesicle, and these vesicle contain specialized chemical. That chemical is called neurotransmitter. That chemical is called what? Neurotransmitter. So when calcium ion enter, so these vesicle containing neurotransmitter will move toward the membrane of this presynaptic nerve, and it will fuse with this membrane. When it fuses with this membrane, so what will happen? This neurotransmitter will release to this gap. When this release to this gap, right? So this neurotransmitter having receptor, having a binding site on postsynaptic nerve. So that neurotransmitter will move toward that postsynaptic nerve. And that neurotransmitter will bind with that receptor. Okay? When it binds with that receptor, so automatically there is specialized channel called sodium channel. That sodium channel will open. When sodium channel open, right? So that influx of sodium channel will take place. Too many, so like more sodium channel, more sodium will enter to this neuron. And this when more sodium enter to this neuron, it means that the impulse transfer from that neuron to this neuron. After that, other channels for sodium will open, and the sodium will start to flow through postsynaptic nerve. So this is general mechanism how how impulse transmit from one neuron to another through synapse, right? I would like to show you a video about this later on. Okay, so you will know about this more by through this link. I will share with you this link. I would like to show you a video about this. Okay, all right. Okay, this is the question. This is very important question. How synapses ensure one-way transmission of impulse? So remember, when that neurotransmitter released to that gap by the process of diffusion, they are moving toward the to the receptor that is present on postsynaptic nerve. Okay, now how synapse ensure one-way transmission of impulse? Let's see. Impulse can impulse can only pass in one direction at synapse. This is because that neurotransmitter is released on one side and its receptors are on another side, another neuron, postsynaptic nerve. So they will move toward from this side, definitely if the receptor is here. So definitely it will move in one direction, it will move toward this receptor. Okay, and there is no way that the chemical transmission can occur in the opposite direction. There is no any other way that this chemical transmission happen, because the binding site is present on opposite side. The binding site is not in another side. So if it is not on another side, so definitely that impulse will move in one direction. It will move in a specific direction. Okay. All right. One thing I just want to tell you about, about morphine. Okay, morphine is actually drug. Morphine are when heroin metabolized and convert into morphine. So this morphine, how it work? Remember, first of all, first you can see, for example, this is one neuron. Okay, this is another neuron. So this one is presynaptic nerve. So what is happening from this presynaptic neuron? A special neurotransmitter called endorphine will release. Endorphine. That endorphine having a special receptor on this neuron, it will bind with that. So when this endorphin bind with that special receptor, it produce feeling of happiness. You feel happy because of this. Now, this morphine is similar to this endorphin. Okay, so and when a person is taking morphine, okay, so what is happening? Instead of this endorphin, morphine will bind with this receptor, and you will feel a sensation. You will feel happy, pleasure because of this. So gradually, if a person is addicted of heroin, so gradually his general endorphin, natural endorphin, decrease in the body because he become addicted of this morphine. So he start to be addicted. He start to defend on the means like he's on morphine. He's taking that from external. So that's why a person become addicted of heroin. Okay, this was just general. All right. Now, types of nervous action: voluntary action and involuntary action. Voluntary action involves skeletal muscles, those muscles that attach with your bones. For example, I'm taking a pen, I'm taking my mobile, whatever. So that actions are voluntary action. That is under your control. But involuntary action, that is not under your control, like smooth muscle, those muscles that are present in your internal body organ, like that is called a visceral organ, like cardiac, heart muscle, lungs, that are not under your control. Their movement of heart is not under your control. That is involuntary action. Okay. Now, one involuntary action here, example is it is exceptional from the skeletal muscle, like knee jaw. Knee jaw, I will show now. Okay. So those action that is not under your control, some reflex action is also not under our control. So that is involuntary action. Involuntary action is not, it is usually like, it's not control of conscious region of brain. Okay. Now, reflexes. A way of automatically and rapid coordination and integrating sensory and input with response from effector. Reflexes, quick and immediate action. It's a quick reflex action. It's a quick and immediate. It is involuntary action. Protection from harmful stimuli. Like, for example, you suddenly a hot object touch your hand, or a needle touch your hand, a strong light fall on your eye suddenly. So you give response to that. Involuntary, without you, like you don't know about that, but you give response. So that is what reflex action. Here one is ninja. This is ninja. It's also reflex. Like, you know, some neurologist, he want to know about response of his nervous system. So usually the neurologist through hammer, he like he take that this part, this like the part of like, you know, this knee. He touch like he, you know, means like he touch that through a hammer with a little force, so his leg move automatically forth and back. So this is called what knee job. So it's also voluntary, right? So what is a reflex arc? Reflex arc is actually the path that followed by reflex action, by impulse during reflex action. So that you can see it here. For example, you touch this sharp plant, or like you touch needle. Okay, so what happen? You can see a strong pain stimulus cause the sensory neuron to generate impulse. So that impulse will travel through sensory neuron to your spinal cord. Okay, and in the spinal cord there is interneuron. So that will, this is interneuron. Okay, that will give impulse to motor neuron. So you can see it here. The impulse is traveling to a specialized path. First sensory neuron, right? And then interneuron, and then motor neuron, and after that, the impulse reach to muscle. So this whole path that follow by impulse during reflex action, this is called what? This is called reflex arc. Reflex arc. Receptor first, sensory neuron, then interneuron, and then motor neuron, and then effector. This whole path is called what? Reflex arc. Right? All right. State two ways in which a voluntary action different from involuntary action. Voluntary action, it's slower than involuntary. It takes more time. Voluntary action needs thought. It's involved conscious region of brain. Voluntary action, it's not inborn. You need training for that. You gradually learn in your day, like in your life. For example, if you are doing, or if you are doing like a game, so you are going to learn that if you know how to write. So writing is voluntary. So you learn that with the passage of time. It is not inborn, but you know, like someone touch a sharp pen or something, need a touch, you give response quickly. That's no need. It's not, that is inborn. That's no need training. But those actions that need training, that are not inborn, that are voluntary action. Okay, it's not automatic, and response is not always the same to the stimuli. The response that you are giving, it's not always the same to the stimuli in voluntary action. Okay. All right. Now, endocrine system. Endocrine system is the system of hormone, right? Hormones are special chemical that's secreted by gland. Okay, so let me tell you something about that. Glands are special bodies, right, present in our body, like glands, thyroid gland, pituitary gland. All these glands are producing special secretion, special chemical. That is called what hormone. Okay, that hormone, remember, that hormone reach to target site. That hormone, for example, that hormone release, so that well reach to target site, that will release, that hormone will release to blood, and through blood, and to blood, that will reach to target site. So it means endocrine system is ductless. It's ductless, right? There is no duct. But hormone will release by gland to blood, and through blood it will lead to target site. Okay, endocrine system hormone are chemical produced by gland, travel, dissolve in blood plasma, and alter the activity receptor on one or more target organ. There is specialized receptor and in target organs, to that it will bind and it will do their function. These are hormones: adrenaline produced by adrenal gland, testosterone is produced by testes, estrogen produced ovaries within female, glucagon produced by pancreas, and insulin produced by pancreas. So adrenaline, it's called flight or fight hormone. It's like flight or fight hormone. It is producing when a person is in danger. This hormone will make you to fight, to compete with the situation, or or, or you can run away from that. Okay, like usually I'm telling to my students, what is the function of adrenaline when dog is coming to you suddenly, and all the changes that come in your body in that time, it's the function of adrenaline. And I will tell you now what are that changes. Testosterone, a male secondary sexual character. It's responsible for when the male is entering to maturity, when he become like mature. So some changes is coming in male body, like with the passage of time, voice become loud, uh, pubic hair on different organs, like uh, different organs, and that hair appear on his body. Okay, so these are the secondary sexual character. I discuss male secondary sexual character in my another video lecture about reproduction. Okay, estrogen is produced by ovary. It's also responsible for female secondary sexual character. Those characters that is when the female enter to uh, puberty, and those changes that coming in female, in which also pubic hair, and like breast development, all these is female secondary sexual character. Glucagon, it's secreted by pancreas. The function of glucagon is raise blood glucose. When your blood glucose become, when your glucose level and your blood become more than normal, so at that time pancreas produce glucagon, and glucagon bring that glucose level to the normal. Okay, while insulin is produced by pancreas, and pancreas actually and insulin actually lower blood glucose level. Sorry, actually let me discuss it once again. This one here is some problem, I'm sorry. Actually glucagon, right? Pancreas producing glucagon. When pancreas will produce glucagon, when the blood glucose level is less in your body. When blood glucose level is less in your body, so what will happen? This glucagon will produce, and glucagon will increase blood glucose level. How it will increase? The store form of glucose in your body is glycogen. So glucagon will convert that glycogen into glucose. Okay, while insulin will produced by pancreas, and this insulin, if the glucose level is more than normal in your body, so what will happen? That if it is more than normal, so this insulin will bring this glucose level to the normal. It will lower that glucose level. How it will lower? This glucose, insulin will convert this glucose into glycogen, or this insulin will increase the breakdown of glucose. So by this way, that glucose will come back to the normal, right? So once again, let me tell you, glucagon, if the glucose level is less than normal in the body, glucagon will increase it. It will rise blood glucose level by converting glycogen into glucose. While insulin, if in the blood glucose level become more than normal, it become more than normal, so insulin will decrease that. How it will decrease the glucose level? How it will lower the glucose, blood glucose level? By converting that glucose into glycogen, that is store form of glucose, or it will increase breakdown of glucose. Is it clear? Now, adrenaline, it's flight or fight response hormones, dog chasing you, seeing a truck at full speed while on the zebra cross, right? So when you are facing this situation, at that time some changes is coming in your body. You are in stress at that time, or sometimes when you are in stress, or when you are doing heavy exercise. Okay, so at that time, the dog chasing you, or truck coming at high speed, or you are in stress, or when you are doing heavy exercise. In these time, in such situations, changes will come in our body. That is the function of adrenaline. So the first is it increase heart rate. Why it increase heart rate? Because at that time I need more, my muscle need more blood. Why it need more blood? So that more energy, so that more oxygen reach to my muscle, and that will utilize for respiration to give me more energy, because I need more energy. So for that, heart is pushing more and more blood to your muscle. Elevated breathing rate, more breathing rate increase, because at that time my body need more oxygen, so I'm taking more and more oxygen. Pupil dilate, your eye pupil dilate, so that you see the situation clearly. Because of that, it dilate. Constriction of arteriole supply blood to digestive tract. From your digestive tract, the blood constrict and all your blood divert to your muscle, because that situation your muscle are doing more. So for that reason, your arteriole constrict means become narrow. So it means less blood supply toward the digestive system, even to your skin. That's why you become pale at that time, because lead blood supply is there to your digestive system and your skin. Okay, and right, dilation of dilation of arteriole of muscle means like your blood vessel that move to your muscle, it dilate. Why it dilate? So that more blood reach to your muscle. Increase blood glucose level, and it increase blood glucose level. It means the glycogen conversion into glucose it increase. It means this having also effect on this having also effect on glucagon, right? So that more and more glycogen convert into glucose, so that your in your blood the glucose level increase, because that glucose will utilize and the process of respiration and will give energy, because you need more energy in that time. Okay, this is the function of what adrenaline. All right, so comparing nervous and endocrine system. Endocrine system of hormone, specialized secreting cells called gland, right? And that hormone travel through blood plasma. Liquid part of blood is called plasma, and it's transmitted slowly. And the response or the action that happen, it take more time, and it is widespread in the whole body. It is bringing change. It is spreading in the whole body. Okay, while nervous system is the system in which the impulse travel in the form of in which the signal travel in the form of impulse. Here was hormone. Here neuron involved, and along neuron, it's the impulse travel along the neuron axon. It is rapid, while this endocrine was slow. It is short-term response. A short-term response at that time it happened, while it is long-term response. For example, a growth hormone produced in your body, it's long-term response. The growth, it will take time. Our glycogen converted into glucose, it will take time. Localized, it's only localized means it's only specific part of the body, or it's only specific part of the body. Okay, so this is the difference between nervous and endocrine system. Now, I would like to show you the video about transmission of impulse across the synapse. It's just animation I would want to share with you.
Action potentials arriving at the presynaptic terminal cause voltage-gated calcium ion channels to open. Calcium ions diffuse into the cell and cause synaptic vesicles to release acetylcholine, a neurotransmitter molecule. Neurotransmitter molecules, acetylcholine, diffuse from the presynaptic terminal across the synaptic cleft and bind to their receptor sites on the ligand-gated sodium channels. This causes the ligand-gated sodium ion channels to open, and sodium diffuses into the cell, making the membrane potential more positive. If the membrane potential reaches threshold level, an action potential will be produced.
Right? All right, students, hope you understand well. Thank you so much.